Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 16th November 2023. The problem statement for today is find the string. And this question has been asked in Google interview. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it says, given two integers n and k, the task is to find the string s of minimum length such that it contains all possible strings of size n as a substring. The character of the string should be from integers ranging from 0 to k minus 1. So problem statement here it is saying that it is containing two integers. First is n, which n is the size of integers. The parameter n represents the size of the substring that needs to be included in the final string s. Here another integer is given as k. K represents the range of the characters that can be used in the string s. The characters are integers from 0 to k minus 1. And we need to find the string s of minimum length, and the goal is to construct a string of a length s that is as short as possible. This string should contain all possible string of size n as substring. Okay, so let's go through the given examples. So in first example here it is saying n is equal to k, n is equal to 2 and k is equal to 2. So both are 2. So here the output we are getting output as 0 0 1 0 0. So in explanation it is given that allowed characters are from 0 to k minus 1, that is 0 and 1. So the string s which we will be forming, that should contain only integers as 0 and 1. And there are 4 combinations possible of size n is equal to 2, that is equal to 0 0 from, if you take these two integer into consideration, then we can construct 0 0, 0 1, 1 0 and 1 1. So to get all these 4 combinations, we have this string s. This contains all possible strings as the substring. So it is also a minimum string. Okay. So if you look at the second example, here n is equal to 2 and k is equal to 3. The output is this one. So allowed characters are from 0 to k minus 1. So the string can contain characters like 0, 1 and 2. And total here 9 possible strings. And actually how we are getting this 9? Actually this one, the number of characters allowed to the power the number of combination we can select at once. So 3 to the power 2, that will give 9. Here in the previous example it was 4. So 2 to the power 2, it will give 4. So 9 possible strings possible of size n. N is equal to 2, which contains the minimum length and contain all the strings as substring. Okay. To understand it in a better way, we will go through the working example. But to solve this problem, we will be using the concept of DFS. Okay, so this problem will be approached using depth first search, which is a recursive algorithm that explores all the possible combinations starting from character 0 to k minus 1 to generate the string of length n. Okay, and here we have the goal to find the minimum length string that contains all the possible string of size n as substring. So if you take this example, then we'll see how we'll construct the DFS. So for that, let me open this. So our DFS method will be something like this, where it will accept k. Okay, k is the size which is given as the input. Current initially it will be initialized with 0, and these two collection that will be set to initial blank, that means empty collection. So initially it will be this way. So from this one, when it will enter inside this loop, so the first next will be calculated as current here it will be 0, because it will iterate from 0 to 1. So it will be 0, and to that we are appending 0. That means the first integer which we are getting as the value of I. So it will be 0 0. So we will check visited contains next, it will be false. So visited will be in this visited array, we will add this next. So visited will contain 0 0. Now again this recursively this DFS method will be called again. So now it will be called with this one 2 0 and 0 0, and this path is still blank. Okay, So next time again it will come here, again it will start from 0 to 2. Here again it will check. Here the current will again start with 0 here, and the first character will be again 0. So it will be again, next value will be 0 0. It will check whether it contains. So it is, yes, a visited array already contains this, so it will skip this one. Okay, so the next time it will go again. Next time it will be 0 and 1 for the next iteration. Okay, so here again it will check whether it visited contains 0 1. No, it is not present. So visited will, in visited array 0 and 1 will be added. So visited will contain 0 and 1. Okay, and this DFS will be called again. And if you look at this DFS, then here as the second parameter we are passing next dot substring of 1. So here it will be passed 1. Last time it was passed 0 because the string was 0 0 there, but this time the string is the next string is 0 1. So we will be passing 1 here. So when we call this method again, so here the first again we will iterate through this loop. So the first next will be calculated here. It will be current here will be 1 because we have passed 1 from the previous recursion step. To that we will add 0. So this will be added 1 0. It will check that does visitor contains 1 0. No, it didn't, because it had 0 0 and 0 1. So it will now get added to this visitor array. So visitor array will become 0 0 0 1 and 1 0. So again this will be called again with this, and we will be passing this entire visitor array. Okay, so this time it will see that both 0 0 and 0 1 both are already present. So it will not enter inside this loop. So this recursion step will be terminated, and in the path 0 will be added. Okay, so next time it will again take the value of next as 1 1, because we have passed 1 here, and since this previous iteration had terminated for the iteration 0, so now the value of I will increment and it will become 1. So that's why we are getting the next value as 1 1. It will check whether the visited array contains 1 1. No, it didn't. So it will get added to this visited array. And now DFS will be again called with next dot substring of 1, which will be 1. So this one k is still 2. Now we are passing 1 as the parameter of current, and this is the visited array. Actually here it will be 1 1 as well, and the path visited is 0. So again we will see that in this step both the next string that will be constructed, that is 1 0 and 1 1, since we are passing 1 here, both are already visited. So even this iteration will terminate, then this recursion iteration will terminate, and 1 will get added to the path because we are passing 1 here. So similarly it will continue. Okay, continue until this entire loop gets terminated, and all the recursive step which we have entered inside the DFS method all will get terminated, and we'll finally get path as 0 1 1 0. Okay, and to this path we will add the first step as the 0 1, so that we get the complete entire string. So one thing it was mentioned in the problem statement: in case of multiple answers, return any length of minimum length, any string of minimum length which satisfy above condition. So here if you see, here it is 0 0 1 1 0, but the string which I got is 0 1 1 0, 0 1 1 0 0. So the path which I got 0 1 1 0, to that I will be adding the initial path in that initial value of 0, so that we get the complete set of all the possible strings. Okay, so this way we will be solving this problem. So with this approach only I have prepared the solution. Let me go to Java editor first. Let me copy this. Here I have added comments as well, so that it becomes easy to understand. So if you see what all things we are doing here, so we are first initializing an empty visited array to keep track of all the visited string. Then we are initializing a node with starting node with the starting node with n-1 0 characters. Okay, then we are initializing an empty list, that is path to store the sequence of the characters obtained during our DFS algorithm. Then from this we are calling this DFS method with parameters k, number of characters, the starting node which was here 0, okay, and visited and path array. And from this one we are calling the same method which we have just seen in this example, this one, that how it worked in calculating all of this. So we are calling this, and as a return to this we are calling this, and here inside this we will be populating this this path array which we have created here, list of integer array. So here what exactly we do inside this DFS function, for each character that is ranging from 0 to k minus 1, okay, we are appending to the current string. Okay, we are appending that value to the current string, that is the value of I, and we check whether this is visited or not. Then we call the DFS recursively with the updated string and add character to the path list. Okay, then we build the final string by appending all the characters here. Then once we come out of this, then we are building the final string by appending the characters from the path list to the empty array, and then we append the starting node. So here we calculate the total path. Total path will be again the k to the power of 2n. That means the number of characters allowed to the power of the size of each substring. So total that will get here, and that will we will be adding into this resultant array, and to that we will add starting node, and whatever will be the size of whatever will be the result of that string, that we will finally return here. And actually this will give us the as the output, it will give the length of the string. So that's why it doesn't matter whether it will be 01100 or 01100. So both will give the same thing. Okay, so here I have added comments as well so that it becomes easy in understanding. So that simple it was. So okay, so let's try compiling this code. So here we can see it has actually returned the length of the string which we have returned from this find string method. Okay, so here it is matching. Now let's try submitting the solution. So here we can see it has covered all the test cases. So this problem is absolutely, and this solution is absolutely fine. So when we talk about the time complexity of this algorithm, so the time complexity of the solution is influenced by the DFS method, DFS algorithm which we have used here, which explores all possible combination. The overall complexity is exponential, mainly determined by the number of characters and the length of the required string, that is n. Okay, the space complexity is also influenced by visited set and the path list. But this approach ensures that the generated string contains all possible string of size n as substring while minimizing its length. The DFS explores the solution space efficiently, and the resulting string is built based on DFS path. Okay, so this was the complete solution in Java. Even I have prepared the solution in C++. So let's move to C++ editor. So let me copy this. So here if you see the logic is completely same. Here also we are creating a starting node, then path, then another the visited array. When we are calling this DFS, and to the last we are adding the starting node. So the logic is completely same here. Only the syntactical difference between C++ and Java that can be seen here. Okay, so let's try submitting this solution. So even with this we have got correct output. I'm submitting this solution. So even with this C++ solution we have covered all the test cases. So this problem has been solved successfully in both Java and C++ language. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.